Assalamualaikum, my name is Azira binti Sairi and my metric number DE1900088. So right now, I present the structure of part line in WebRISC. So here as we can see, there's a 5 stage in the structure of the part line. So it gives the 5 color to differentiate the face. So from the pink color till the red color, it a fresh face, and from red color to yellow color, it a decode face, and from yellow to blue, it a execute face, and from blue to green, it a memory face, and after green, this is a write back face. So and here to load the program, we can go to the load program and click the group program, and then we can choose there's a simple calculator, memory reference, vector, real data hazard, store example, and Siska and data example. So for the example, here I choose the data hazard example. After we choose the example list, we can see here there's a assembly editor, and here list of that instruction, and this for the as we can see, there's a assembly code here, and then we can load the assembly code into the memory, and then we execute all. Then after we click the execution table, we can see that there's all instruction in 9 cycle. Execution complete in 9 clock cycle, and from this we can see this is a instruction memory. There's a immediate, RS1, funds, and RD, and offload. Then there also a data memory. As we can see, we can select the memory to for the display, and here I choose I click here and it will show here, and this is a list of register. From here we can see that there is a number until the register 8. Okay, that's all from me. Thank you.
Assalamualaikum, my name is Farnabila binti Nazan. Metric number CE1900054. For this project assignment, I'm going to explain about the data hazard, illustrate and simulate pipeline concept hazard or branch delay. As you can see, there are 5 into the 5 phase. The pink is for the fetch, the red one is for decode, the yellow is for the execute, the blue one is for memory, and the green is for the write back. First, we need to load the program and choose the data hazard example. This is the assembly editor example, and I'm going to use this. After that, load it into the memory. Okay, and we can see the instruction memory, data memory, and the register. Okay, Then we need to execute the commands into the pipeline. If I click the step forward, you can see the first instruction is in the fetch stage. After that, the instruction goes to the red one, which is decode the instructions. Okay, the third stage is to execute the instruction, and store to the memory. And the last is the write back. And we step forward until it complete the cycle. And we can see the execution complete in 9 clock cycle. And we can see the execution table. For the execution table, for the instruction 1, we can see the instruction is going through fetch without any disruption, and into the decode stage, execute stage, memory, and write back. For the second instruction, the fetch is going to be at the second cycle, followed by decode, execute, memory, and write back. And also for the instruction 3, the fetch is going at the third cycle, followed by decode, execute, memory, and write back. And the fourth cycle also, the fetch start at fourth cycle, followed by decode, execute, memory, and write back. And the fifth cycle, the fetch start at fifth cycle, followed by decode. Okay, at the fifth instruction, the fetch is going to start at the 5th cycle, followed by decode, execute, memory, and write back. I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Noshafawati binti Kamudin, and my matrix number is CE190211. Today I'm going to present our project, which is the concept of computer architecture and organization. So computers come in a variety spaces. Assalamualaikum warahmatullahi wabarakatuh. My name is Noshafawati binti Kamudin, and my matrix number is CE190211. Today I'm going to present our project, which is the concept of computer architecture and organization. So computers come in a variety shapes and size, and they serve a variety of roles in our daily lives. For example, when we use an ATM or scan the barcode at the groceries, or use a calculator. So that is actually we accessing a computer. So to understand the computer, the language, or should I call it as a machine language, are required to communicate with computers. So basically, there are three language, which is machine level language, assembly level language, and also high level language. And those language consists a code of program. And computers essentially understand only zeros and ones, which is a big number. And to execute a program, we have to run the code. So a system user instruction, user instruct the system to perform the code, and the CPU will fetch one set of instruction and implement the stated function. But however, during the execution, there were multiple instruction overlap occur. So the gather instruction, we call it as a pipeline. So pipeline act as enable the systematic storing of execution of instruction, and pipeline enhance the overall throughput the instruction. So each segment of pipeline contains of an input register and combinational circuit. So fetch, decode, and execute cycles employed to boost the computer system throughput, which is happen in a CPU, and the pipeline will operate more effectively if the instruction cycle is split in equal length parts. So now I'm going to show the simulator we use for the project, which is WebRISC -V, which is the pipeline data path simulation online version. So we can see here comments and also the schema layout of the CPU. And then let's say we load the program. For example, we choose data hazard. So this show the assembly editor, or should we call it as a code for data hazard. And then next step, we load into the memory, and then we execute all. And then we can see from the execution table, these are the basically execution that happen in CPU. And then the table consists of 9 CPU cycles. And this right here at the left one is the instruction. So for the first stage, for the first instruction at T0, at 0 and 1, for the first stage, fetch happen, and then second stage is a decode, and the third stage is a execute, and fourth stage is a memory access, and the fifth one is the write back. And then for the second instruction at T1 at 02, the fetch happened at the second stage, and the decode is at the third stage, execute at the fourth, and then a fifth stage is a memory access, and then the sixth stage is write back. And then third instructions, T2 for T2, T0, and T1, fetch happen at the third stage, and then fourth stages is a decode, and the fifth stage is a execute, and the sixth one is a memory access, and then the seventh is a write back. So it moves in a sequence, and the next one is at T3, T0, and T2. So the fetch happen at the fourth stage. Then the fifth is a decode, and sixth is a execute, and the seventh stage is a memory access, and the eighth is a write back. And the last instruction is at T40T2. The fetch placed at the fifth stage, and then the sixth stages is a decode, and seventh stage is a execute, and the eighth stage is a memory access, and the last one is a at the last stages is a 9, which is write back. So as you can see here, these are the instruction memory. And so we have the data memory, and then also the register. It's all in the binary value. So that's all from me. Thank you very much.